Well, it's a whole new year, and we're kicking off with a lot of the same old stuff. Now, I guess part of the same old stuff is I'm still here in Norway. It is actually not as cold as I thought it'd be right now. Like I'm in a, for those of you just listening or watching, I'm in like a light sweater. Apparently it's 5 degrees, which is not too bad. I must be acclimatizing a little bit because I don't have the big jacket on. So anyway, that aside, other stuff is same old business as usual in terms of the cyber things. And there was two tweets I've made in the last 24 hours I want to start with before I talk about the blog post, which I'm just about to publish, but will publish before this video is published. Two things that really struck me. Now, number one, I just went down to get a sandwich for lunch, and I've gone down to the shops, and I've looked at my phone because I'm standing in the queue waiting for the cashier, and it's like, why am I connected to a network? I'm looking at my tweet here. Why am I connected to a network called Washer Samsung? And not only why am I connected to a network called Washer Samsung, because okay, I do have a Samsung washing machine at home. It does broadcast an SSID because reasons. Why am I connected to it? And it's a secure network. It's got a padlock. So is it the same pre-shared key? And I tweeted this before. I said, walking around a grocery store on the other side of the world, and my phone decides to jump on a random washing machine's access point because it's broadcasting the same default SSID as the one at home. Welcome to the year 2020. Because this is kind of this crazy dystopian future now where my phone could be roaming around the world and connecting to what it thinks is my washing machine. I don't know exactly why I connected to the washing machine. I was curious. But it's connected to someone else's washing machine. So it's like, okay, we've got connected washing machines following me around the world, and also they're sharing the same keys. Like, what could go wrong with that? Now, oddly enough, I remember when I did connect to my washing machine, and I remember tweeting about it at the time, because I was like, why is this thing broadcasting an SSID? I remember it just broadcast the SSID so that you could connect to it, and then you could connect it to your Wi-Fi, because you really want that as well, right? A whole other story about how to have a VLAN for IoT shit. I'm actually going to talk about that in my NDC talks in Oslo later this month. NDC Oslo, NDC London as well, for those of you in either of those areas. So that was a rather odd thing, and again, like it just feels very 2020 already. And the other thing that felt very 2020, just insofar as this is just so reflective of how difficult life online has become because shit has got so crazy. TikTok. So not TikTok Track, the dodgy watches with the security issues. This is TikTok, the video. I don't even know exactly what it is. I just know it's got a lot of random videos on it. I'll come back to why I was actually creating an account in a moment. This is TikTok, the video sharing social media platform, of course, the one which is meant to be Chinese, or apparently is Chinese owned, and people are very worried about how much data now gets sent back to China. I'm sure in China they're probably very worried about how much data was sent back to the US, if you could actually access any of the US social media platforms from there. Other story. I've gone to TikTok to create an account. I'll come back to why I was doing this. Gone there to create an account. And I've generated a password in 1Password, which is the right thing to do. Comes back, it says, password too long. So, okay, great. Like, not exactly unusual. I will create a shorter one. And then it came back and it said, so again, I just regenerated one with crazy password criteria in 1Password. It comes back, it says, password must be between 8 and 20 characters and a combination of numbers, letters, or special characters. Okay, I can do this. So I make another change. And then the third screen cap I've got in this tweet is it comes back and says, password can't contain special characters. And it's like, but you just said it's got to have special characters. So how are we back here again? So, 2020, my washing machine is following me around the world, except it's not my washing machine, it's just another one using the same authentication key, and I still can't create passwords on websites. Now, why was I creating a password on TikTok? Because many people did reply and said, aren't you too old to have a TikTok account? Again, I didn't really know much about TikTok, but inevitably it's used by people much younger than me. I created an account there because I saw something, but I can't remember what it was. It was something on the news, and I was like, there's a place I don't have an account and I've never seen before. I've got a bit of downtime. Let's see what the hell TikTok is about. Now, I did eventually manage to create a password, but I spent so much time trying to do that, I ran out of time to actually see what TikTok is about. So I can't answer that question yet. If you know what TikTok is about, let me know. So, good beginning there. Now, on to something of a little more substance. And this relates to cookies and same site cookies. Now, this is actually a really, really important thing. I've had this on the back burner for a little while. It was nice just to sit down and write a technical blog post with no politics or crap or other stuff like that. No people saying crazy things about SSL. It was like literally just about a security mechanism built into all the major browsers. Same site cookie attributes have been there in Chrome for years and years and years. I can't remember when they actually started. It must have been 4 or 5 years ago. I didn't actually put that in the post because it's been there for so long. Fully supported in Safari and Firefox and Edge and all these sorts of things as well. So it's something that's been around for a long time, but we never tend to use. Now, I say that in a very general sense. Every time I do a workshop, and one of the first things we do in the workshop is we look at cookie attributes. And I say to everyone, you know, what's an HTTP only cookie? What's a secure cookie? What's the same site cookie? And the same site one is the one that people never know about. It's actually really important to know about because Chrome is going to make a change in about a month from now, which is going to break websites. Not all of them, but a lot of them, particularly the ones doing screwy things, and particularly if you're in the enterprise doing exactly the sort of screwy things I've seen a gazillion times there before. So, just by way of background, cookies are very promiscuous. Well, my working title for this blog post, assuming I don't change it before I post it, probably in the next 24 hours, is Promiscuous Cookies and Their Impending Death via the Same Site Policy. Now, what I mean by a promiscuous cookie is a cookie will go with any request so long as the request is valid for the domain, the path, if it's got to a path, it's got to be an HTTPS request if the cookie is flagged as secure. That's it. It will just go. Get request, post request, a request to an image, a request to set the source on iframe. Anything like that, the cookie will go with it. Now, this is, on the one hand, one of the glorious things of the internet because cookies just automatically follow you around. So as developers, you can do things like write auth systems, which then persist cookies in a session cookie / auth cookie, and it just automatically gets sent with the request, and you don't have to cobble together bearer tokens and things like that, which of course are advantageous for other ways, but let's just stick with the cookie thing for the moment. So that's fantastic, but the problem is that because cookies are so promiscuous, they do go along with all these requests regardless of where the request originates from. So if you can be an attacker and create a page which, say, makes a post request to a resource on a target website, and a victim comes along, visits that page, their browser's tricked into making the post request, and that post request has a whole bunch of form data, because the attacker can set that, and the cookie gets sent automatically, say it's the auth cookie, then it's an authenticated request posting data which, by definition of the verb, should actually change some state on the target site. And now you've got cross-site request forgery. And we tackled this with anti-forgery tokens. So we have a token that gets set in the cookie and a token that gets set in the body. And when you send both of these things with a legitimate request, normally on the same site, they get to the other end, the web server gets them, grabs them, makes sure that they match and they belong together. Now, just to be clear, they don't have to be identical. Different implementations have them as identical versus cryptographically signed with reference material inside each one to make sure that they belong together. The point is that these two values, the one in the header via the cookie and the one in the body via the form field, need to belong together in an anti-forgery token implementation. Now, if they do, request is fine. If they don't, the request fails. And this works because the attacker never knows what the value of the, I was about to say the value of the cookie. The attacker never knows the value of the cookie, but the cookie does get sent automatically with the request. We've had this discussion about them being promiscuous. The value in the form, the attacker never knows. So what it means is the attacker can create like their forgery page and they can trick the victim's browser into making a request which will send the cookie, but they never know the form value. So the form value is not there, goes to the web server says these things don't belong together, therefore fail the request. In a way, it's a bunch of sticky tape. In another way, it's not too hard because many frameworks make it very easy to do anti-forgery tokens. ASP.NET MVC has an HTML helper that you drop in your form and a validation attribute that you jump from your, or drop in your controller action, which then says make sure that all of these things belong together and work or fail the request. Other frameworks do similar things. Problem is lots of people don't actually use them. So either they're rolling their own stuff and they just don't do anti-forgery tokens at all, or they've seen them before and they don't understand why they're necessary. And they're sticky tape anyway. They're basically just like spackling over holes that were in the original design of the web. So, same-site cookies come along. And the premise of same-site cookies, we've got three different values that we can add to this cookie attribute. None, which is, as of today, in Chrome 79, what it defaults to if you don't set one. In fact, I'll rephrase it. If you don't set a same site policy, then there is no same site policy and it behaves just the same way as if you were to set same site. None. You also have a lax policy and you have a strict policy. And I'm just flicking through what I've written in this blog post because what I've ultimately ended up doing, I really wanted people to sort of see for themselves how this works. So I've actually set up a couple of websites. So just sitting here on azurewebsites.net domains. I didn't go and purchase domains for these. But there's one website which acts as like an origin website, and it sets a whole bunch of cookies, and then it can display the cookies back in response to a request. Then there's another website, which I've called an external site, which then does things like makes a GET request, makes a POST request, puts an iframe of this in there, pulls an image from the origin site into the external site. And what you'll end up seeing is that depending on the policy, cookies may or may not be sent. So I'll give you a really good example. Let's have a look here. If you make a GET request, as of today, if you make a GET request in Chrome 79 from an external site to the origin site, so this is the site that set the cookie, then a cookie without a same site policy will get sent. A cookie with the same site policy of none will get sent. A lax policy will get sent. A strict policy will not get sent. So if you had a same site policy and you set it to strict, and that was on, say, your auth token, if someone was on another site and then they followed a link, made a GET request to your site, the auth token would get sent. It would no longer be an authenticated request. They'd effectively appear logged out. So that's what happens on a GET request. Now, remember, GET request, though, at least the semantic intent of the verb is that it doesn't actually do anything. It just returns a result. It doesn't change any state. If you turn that into a POST request, the behavior changes a bit because a POST request won't send a same site cookie with a policy of lax. Now, this is really, really important because this is where things are going to change later on. So if you make a POST request from an attacker's site to the victim's site and you have a same site policy that's either lax or strict, then what's going to happen is that cookie is not going to get sent, ergo the CSRF issue goes away. And this is really the heart of the problem. This is what we're trying to fix. We'll come back to how we're fixing this. We, the industry, Chrome. Iframes. So if you have an iframe, as of today, from an origin website that you put inside an external website, then a cookie policy or a same site policy of none, that cookie is going to go there. If you don't have any same site policy at all, that cookie will go there. But if you have either a lax or a strict policy, it won't go there. If this is all starting to sound like word soup, read the blog post, it's in there. Now, it's the same behavior with an image. So if you put an image on an external site embedded from a site which set cookies, same site policies of either lax or strict, that won't cause the cookie to be sent. So they'll effectively be anonymous requests that go back to the site. Now, here's the crux of the entire thing. When Chrome 80 hits in early February, any cookie that doesn't have a same site policy will be treated as same site lax. Now, what that means is that if you've got a website and you are relying on people to make POST requests from an external site to your site and you're expecting to have a cookie, the cookie will no longer be there. For example, if you have some screwy enterprise style application where you've got two different apps, two different domains, and one of them makes a POST request from the external site to the site which originally set the cookie won't go. If it's used for something like persisting authentication state, then it's going to be an unauthenticated request. That is going to break stuff. That's super, 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 super important because I bet you we're going to get into early next month and a whole bunch of people are going to go, well, I don't know what's wrong here. Stuff used to work yesterday before Chrome automatically updated. So that's interesting. It's going to break stuff. Now, something else on this as well, and I'm just going to read the term here, or I'm going to read the quote because this is interesting. So this has come from Google. They are going to deprecate and remove the use of cookies with the same site none attribute, but without the secure attribute. Any cookie that requests same site none, but is not marked secure, will be rejected. Here's why it's important. A bunch of people are going to see this same site change come into Chrome 80 and they're going to go, I don't want to have to deal with any of this. I want my cookies to behave just the same way as they always did in Chrome, so I'm going to set same site none on my cookie. Job done. Except that's only going to work if they serve the request over HTTPS. Now I love this because it's driving people more towards doing HTTPS. But I'm also conscious there are so many examples, particularly within enterprise, where people are not doing HTTPS across all of their things. And of course, it's in enterprise where people are also going to be doing screwy things like passing authenticators, data across apps by post request and things like this, which of course this change is going to break. So there are some really interesting nuances coming there, and I'm just really curious to see how much stuff will break. There is a resource here I've linked to from Microsoft where they've said, look, this is actually going to break a bunch of OpenID Connect stuff unless you update. As of .NET 4.7.2, there is a same site attribute of HTTP cookies, which is an enumeration where you can set none like strict. So that's good. I've actually got to update a couple of my things and make that a bit more explicit as well. But I just reckon it's going to be really, really interesting to see how much unexpected stuff breaks, because this is one of these things which is just subtle enough that it's not going to be immediately obvious. It's not like someone's going to be using this app after Chrome updates and something will break and there's an error message which says it has broken because of this reason. It won't be that. It'll be one of the like 50 different cookies that some obscure enterprise app is setting, and that's not getting passed because of the nature of the request, and it doesn't work and it's not immediately obvious. Now, we've known about this for ages. I wanted to write something earlier, but been busy. So I thought I'd get this out now and kick the year off by actually writing some more technical content, which it has been a little bit hard to keep up on lately, if I'm honest. So I hope you enjoy that. I've enjoyed writing it and just basically focusing on technology for a bit. So last thing this week is my sponsor. I'm trying to do this a little bit faster because it wasn't cold when I came out here, but now it is. So the sponsor is Varonis. They are still promoting their free video courses, 7 hidden Office 365 settings that you can only unlock with PowerShell. These are the Office 365 security settings. And again, Varonis are good people. I've done a bunch of courses for them as well, which are also available for free. So please go and check out what they're doing. And I appreciate them being the first sponsor of 2020. So that's it for Here From Now. I'm back on an airplane to Australia tomorrow. So next week I'll come to you from somewhere significantly warmer. And for all of those asking, the area of the country that I live in has not been affected by bushfires in any way, but it has been, from all the news I've seen, just absolutely catastrophic there in recent weeks. And it's dominated the headlines, not just on my Aussie news, but even sitting in a train in Oslo today, it was all about bushfires in Australia. So not a fun time for a lot of people down there, and hopefully when I go back I'll be able to have a bit of relaxing time with friends and family and have the luxury of not needing to deal with that. Thank you very much for watching. I hope you liked this week's update and hope you really like the same site cookie stuff, and I will come to you next week from Oz. See you later.